Hi, Professor Tulay.
Hi.
Welcome to our webinar.
Thank you so much. Let me first of all thank you for this nice organization, and of course thank you to all members of committee. I appreciate joining here and being with you. Thank you so much.
We do thank you also. Let me introduce you. Professor Tulay Yildirim is attending from the Arabic Turkey. Today she is going to give a speech titled by Linear Skew Cyclic Codes over FpR. If you are ready, you can share your screen.
Thank you. Is it fine?
Yes, it's perfect. If you are ready, the microphone is with you.
Thank you. Thank you so much. Today I'm going to talk about my subject. My main subject is about the codes. Special subject is a linear skew codes over the FpR ring. First of all, let me introduce my contents. Our contents include our objectives, preliminaries, the gray map of the code, and this is the one of our main subject is the generator polynomial to find the generator polynomial of our skew cyclic codes, and it will be ended with our references. First of all, why we study this subject? Because our aim is to characterize the skew cyclic codes over the new defined ring, which is FpR. Here R is Fp plus VFP. Fp is a finite field with the prime number p, and V square is V. In the present study, we also investigated the algebraic structure of this code in details. Then describe the main map, which is called gray map of the skew cyclic codes over our new ring FpR, and also determine the generator polynomials. Our study is ended with the defined non-degenerate inner product. I mean, it's called also Euclidean inner product, Hermitian inner product, and provide a criterion for the test to test the self-orthogonality. First of all, let me introduce our rings. Here, we are specially study over the FpR. Here, the Fp is a finite field with the prime number p. And R means that Fp plus VFp. Here, our elements are B plus VB, B and D elements of Fp with the property that V square is V. This is a commutative ring. And we also know that it has two maximal ideals. That's why it's called semi-local ring with the V and V minus 1 minus V. And there are over maximal ideals isomorphic to Fp. By the uniquely express, we can express elements of R in this form. By using this form, we define two codes. C1 is the coefficients of the V, C2 is the coefficients of 1 minus V. And also by using the C1 and C2 codes, we can uniquely express any code over R in this form. And also, of course, if you are talking about the ring R, we should always describe an automorphism, theta. Here, theta is the composition map of automorphism P and theta 1 defined in our references tree. And it sends V plus VB to the B to the P 1 minus VD to the P. And also, its elements are defined as AX and BX and is elements of Rx theta. This is the polynomial ring, I mean. This multiplication is defined by using the automorphism over R. Also, this is, as I said, that it's the polynomial ring. Its elements are coefficients are coming from R. And what about the R new ring, FpR? FpR, we denoted FpR with a binary. I mean, A, B plus V. Here, the A is elements of Fp, B plus VB, VD is elements of R. Also, if C is a skew cyclic cos over R new ring, and alpha is the set of Fp, shows it's the coordinate positions. Any code from C over FpR are denoted in this form with the binary operations. Also, let me introduce the cyclic shift. What is the meaning of cyclic shift for our new ring? we define PC and theta automorphisms of Fp and R respectively. Then we said that a cot C over FpR is Skew cyclic cutoff length alpha plus B if C is an R modulo of FpR and C is closed under this cyclic shift, and we introduce this cyclic shift in this form. And if you want to give the relation between the ring and a finite field Fp, we define the map delta, which sends B plus VB elements of R to the B. It has also scalar multiplication by star. We said that if you multiply any elements of R with the FpR, you should take the first binary under the delta homomorphisms. And we give this some basic and well-known notions for our new ring FpR. We said that the cot C is FpR linear Skew cyclic cutoff length alpha plus beta if and only if C is a left Rx theta submodule of R alpha beta. Then we define the Euclidean inner product for our ring. We said that X and Y is defined in this such a summation form. And of course, after the earlier Euclidean inner product, we have to give the duality definition. Duality is the well-known definition, except we take our elements here, Fp alpha, R beta. And if C is an FpR skew linear cot of length alpha plus beta, with the beta is an even integer numbers, then we show that dual of C is also Skew cyclic cot of length n. Also, then we start to define and introduce gray map over the ring FpR. We said that we always know that gray map satisfies relation between the ring and field for the cots. So we said that if C is a cot over R, we can move these cots to the field from R to Fp to N. Why we took to N? Because here R is Fp plus VFP. For any cot, we define gray map as which sends C to the BC, BC plus DC. Why? Because here C we took as a N tubes. What about the gray map over FpR? FpR has two elements, A and B plus VB. Now we said that under the phi map, we can define gray map as A, B, B plus B. This is the extension version with the N tubes of the gray map. If C is Fp linear cot, under the gray map, it's easy to say that phi C is also Fp linear cot. And we define the basic proposition, and we show that if phi is an Fp linear distance preserving map, I mean from Lie distance to the Hamming distance, it is preserving under the map of gray map. Let's see be a linear self-orthogonal cot over FpR. Then we show that under the gray map, which is still self-orthogonal cot over Fp. And if we take C as a FpR skew cyclic cot of length n, I mean alpha plus beta, then phi C can be written as a direct product of C1, C2, C3, where C1 denotes cyclic cot of length alpha in Fpx, alpha minus B1, C2 and CTR denotes skew cyclic cots. And for the new definition about the quasi-cyclic cot over Fp, C is a linear cot over Fp and it is summations of Mi. We denote Fi in this form. We said that if F is a product of Fi, then C is skew generalized quasi-cyclic code. For this code, we define a new map as a lambda. By using this definition, we prove that if phi is a gray map, then phi cyclic shift equal to the lambda phi. And then if C is a linear code of length alpha plus beta over FpR, then C is an FpR linear skew cyclic code, or if and only if it's the gray map is a generalized skew cyclic code over Fp with the length alpha plus 2b. When we come to the generator polynomials for the R neighboring FpR, first of all, we said that here the zero vector or zero polynomials are denoted by 0. If we are talking about these notions, which means that f of x is a right or left divisor of x to the alpha minus 1. First of all, we prove that. Let I1 be an ideal of FpR. It means that for any polynomial gx taken from this polynomial ring, then I1 is generated by left divisor of x to the alpha minus 1. And now we take another ideal which belongs to the R x theta, such that it's the polynomial coming from R x theta over x to the beta minus 1. Then we show that this ideal is principally generated left Rx submodule of this polynomial. This is one of our main theory we proved. We show that, let's say the FpR skew cyclic code of length alpha plus beta, then this C is generated by these polynomials. Here f of C is a generator polynomial of Fp, xpc, C, Jx and Hx is the Jx also polynomial of Fp, Hx is polynomial Rx theta. Also Ra, Hx can be written V H1x, 1 minus V H2x. And after the theory, it's easy to give this corollary, I mean C over FpR can be written with these also generator polynomials. This theory also are another but the main theory, because by this theory we also decided basis of the code. We said that if C has such a generator polynomials, then C for these spanning sets, C has such a minimal spanning set. And also by using the previous corollary, we show that this basis can be seen in another forms. For the generator polynomial gx0, it has such a minimized spanning set form. For the generator polynomial jx hx, we have such a polynomial, such a minimized spanning set. And for the generator polynomial union of g of x0, j of x hx, it has union of these minimized spanning sets. Also, we still continue to improve our study with giving some examples nowadays. These are our basic references. There we go. Thank you for your all patience and attention.
Thank you very much, Professor Tulay Yildirim Turan. It was a very nice and well-organized presentation. Let me ask for question and answer. Is there any question or valuable comments for Professor Turan?